thank you. I think I'm in.
Yeah, you are. I'm live. And we'll stop it when you're done.
Great, thanks, Rich.
Okay, bye.
Just had a minor problem there getting it. I don't know why. I think I was logged into the wrong thing. Okay, welcome to maths. We are going to be doing an action hour starting any minute now, 3 minutes time. It's going to be focused on finding out, this is for first years, finding out what you haven't done yet so that we can make a schedule, okay? So I meant to put all of these FAQs into the description, but I couldn't get it working. So I'm just going to read them out, okay? So these are my questions. And those of you who are staying the whole time, can you answer people's questions if they say these? So what is happening is that Taylor Tutors are doing lessons every single day. So I'm doing 12 o'clock every day is first year maths, 1 o'clock every day is second year maths. Second years, I would recommend that you don't have to come to the 12 o'clock one, just to come to the 1 o'clock one. And if you are going to do maths from 12 to 1, do something more useful like past papers or practicing questions and stuff like that, rather than listening to me talk about first year stuff. But if your first year stuff is really wobbly, then obviously you're welcome to do both hours. So that's what's happening. How long is it? It's 45 minutes from the point at which I start. We recommend that you use these 45 minutes called action hours. They are really, really tight in terms of timing. So we have a clear focus. We set a timer for 45 minutes and we are not distracted during that 45 minutes. And when the timer goes, we stop. Okay. So this live will be 45 minutes from the point go. This is AS, not A2. A2 will be at 1 o'clock, 1 till 2. It's all exam boards for maths because the all three exam boards use the exact same specification. There is a tiny difference for AQA that don't do ladders and don't do continuity correction. Other than that, it's exactly the same. So this is all exam boards. Okay, can I ask you about grades and uni places and COVID and blah, blah? Basically not in this session, no. This is a lesson. This is maths and we are working through the Exambulance content through the schedule that we've put together for you. But we will be doing our Monday check-in at 6 o'clock. So if you want to come back at 6 o'clock for our check-in, then you certainly can. And we can talk then about what's going on and what we've heard and all that kind of thing. Are you going to do this every day? Yes, I am. Everything is changing all the time at the moment, but the plan for the moment is certainly that we are going to do 12 till 1 and then 1 till 2 will be maths every day, Monday to Friday. So I need to introduce you to the Exambulance. I will pull up the screen with it on. I think you can get it. So if you go to the Taylor Tutors website, then on the Taylor Tutors website, you will be able to see a thing that says Maths Exambulance. There is a free course and all of the resources that I'm using in the YouTubes are going to be on that course, okay? This is what it looks like inside. Hopefully you can see that. So the study schedules that we're sticking to, why can't I click on it? Weird. Is it because I can't click on it because I'm sharing it? Maybe. I'll try one more time. Yeah, so all of the resources are in there. If you have any problem at all getting your course set up, I can't believe you will. We've tried it a few times and it does work. So go to the Taylor Tutors website, click on the Exambulance, sign up for the maths one. Oh, it did work. It was just being really slow. And all of the resources are in there. So what we are doing today, the purpose of today is we are going to do a starting phase 1, which is finishing the AS content and making good revision notes. That's phase 1 of our schedule for first years. In the second year hour, we're going to be properly finishing the A level and making really good revision notes, just in case you need to take that exam in September, because I think a lot of you will. Some of you want to take it. I know I've spoken to a lot of students that have just said, I want to do it regardless. I want that opportunity. And other people are going to be worried about if their grade isn't what they need, then they need that opportunity to do it. First years, we've got this 3-phased process that we're going to be working through. So we're starting with finishing the content. So the aim for today is for everyone to finish the content. If you have a printer, could you go to the maths course maps and print out the first one, the pure? Okay, so this is what we're going to be doing today. First years print this one, second years print this one, and that's what we're going to be using. You don't have to print them. You can use them on an iPad and annotate, or you could just use a piece of paper and write on top of that. And the idea, the aim for today is that we're going to get a good idea of what you haven't yet done, and then we will have a proper plan for making it get done, basically. Okay, AS. I will just get this set up so you can get your paper ready or print or that or whatever you want to do. A plugin is required to share an iPad. No, it isn't. I do it all the time. Oh, no, it is plugged in. Let's see if this shares. It's saying on your iPad, connect to the Wi-Fi. I am on the Wi-Fi, I'm at home. Why are you? Sorry, just give me a sec. I don't know why this is having a little tantrum. Yeah, I am on that Wi-Fi. This is going to be difficult if I can't share my screen, to be honest, as always with maths. I'll try again. Okay, it's saying I have to tap screen mirroring. Right, I'm just going to have to do it with this screen and just talk you through it, I think. Sorry about that. I was going to write, I've got slides all set up and everything, but never mind. We shall do it like this. I will download this. We'll just do it on the screen like this. Okay. Oh, this is annoying. Now I can't see what you're saying, so I'm trying to get that at the moment, is what I'm doing. There's the chat. Okay. Right, we're ready to go. Can you see the map? Can you see the graphs bit of the map? Cool, okay. Right, so action hour, I'm going to set a timer for 45 minutes. And our target for this action hour, we have to have a target so that we're not distracted. Our target is to go right through the pure summary spec and to decide what we're going to do and not do. Kind of blurry. I know why it's kind of blurry. What I'm going to have to do is I'm going to make it unblurry, but then I won't be able to see the chat, annoyingly. So I'll have to just like have a look every so often at the chat. Sorry, I don't know why this is going weird. Okay, timer is on. Okay. Right, so I'm going to talk and then you're going to think and you're going to just cross off what you've done and highlight what you haven't done, okay? So graphs. Linear modeling is where you, in order to do linear modeling, you have to know the equation of a line is in two forms, y equals mx plus c, and mx minus a is y minus b, or you might do y minus y1 is mx minus x1. And then you need to know what those bits are. So in y equals mx plus c, the m is the gradient and the c is the intercept. And in mx minus a is y minus b, or y minus y1 is mx minus x1, in that, the m is the gradient and the x1, y1 is a point on the line. So if you get given some information, this is the modeling thing, it's all in a context, or maybe you're shown a graph and you're shown some of the features of the graph, like you might be able to work out the gradient or the y-intercept, then you can construct the line. You can work out, my carrot juice, you can work out what it was that the line equation should be. Yum. Quadratic modeling. Same idea, okay? So with a quadratic, we've got three forms: factorized, completed square, or expanded. Now, what's the advantage of each of these? Let's say I know the roots. Well, if I know the roots, then I know the factors, because each root gives me a factor. So that would mean that I could reconstruct the equation from the roots. The thing to be careful with here is that you put a capital A at the front. So if the roots are 1 and 2, you have x minus 1, x minus 2, but you must put a capital A at the front because we don't know whether it's been stretched or not. Exactly the same thing with the completed square and the link to the turning point. So if we've got a graph and we know that the maximum occurs at a certain point or the minimum occurs at a certain point, then we can construct the completed square. If the turning point is 1, 2, then the completed square is x minus 1 squared plus 2. So that coordinates of that turning point slot beautifully into the completed square. Again, we don't know whether or not there was a stretch, so you must have that capital A at the front. Capital A, x minus x coordinate squared plus the y coordinate of the turning point. So roots, factorized form, turning point, completed square form. If you don't want to use either of those and you want to just use the expanded form, ax squared plus bx plus c, you've got three unknowns there, don't forget, a, b, and c. And only one of them is obvious, the c, the intercept, the y-intercept. So then you'd have to sub some information in to get the other missing things. But really, the linear modeling, the quadratic modeling, and the exponential modeling, it all comes down to writing down the equation, so knowing the structure of the equation, and then subbing in a point, finding a variable, subbing in a point, finding what b is, subbing in a point, finding out what c is, until you found out the equation. Sketching factorized polynomials, you need to know that if a bracket, when it's factorized, if a bracket has a squared on, that's a touching root. And if a bracket has a cubed on, so like the graph goes whoop, like that, or it goes up and touches and comes down. Or if there's a triple root, it will be an inflection point. So it will come up, touch and go up again, or maybe come down, touch and go down again, like that. So knowing that single roots, if this bracket is 0, the graph is just going to slice through at that point. If the bracket is squared, that's a gentle touch. And if the bracket is cubed, it's a up through up or down through down inflection point. Graph transformations, you probably do know. So you need f of, and then inside the bracket does the opposite of what you think. And then if it's outside the bracket, like f of x plus 1, it goes up 1. 2 f of x, all the y coordinates get doubled. That's what graph transformations is, knowing that stuff. Transformations of functions is basically graph transformations, but the other way round. So instead of me saying, here's a graph, can you sketch for me f of 2x? Instead of saying that, I say, here's a function, not the graph, the function. What would the equation be if I took this and stretched it scale factor 3 parallel to the y-axis? What would the equation be? So it's working in the other direction. So that's what transformations of functions is. The same rules. So f of x plus 1 goes left 1, but applied not to a graph, but to an actual equation. Sketching transformations of, I forgot to put x squared in there, but you need to know x squared, basic graph, left, right, up, down, stretch. The completed square is perfect for showing you what that looks like. But you can do the same thing with x cubed next to the 4. X cubed, up, 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 touch, up, up, up. And you can stretch it and you can move it left and right and you can move it up and down. Same thing with x to the 4. X to the 4 looks basically the same as x squared. Left, right, up, down, stretching, reflect, all of the normal graph transformation stuff. You also need to be able to sketch 1 over x and 1 over x squared. So 1 over x is the one that goes woo, like that in quadrant 1, asymptote, asymptote, and then same in quadrant 3, woo, like that. So here and here, knock my lamp over. That's the 1 over x. 1 over x squared is all above the x-axis because it's all positive. X squared is always positive. So 1 over x squared is always positive. It's always up high, and it comes down the y-axis, opens kind of like curtains in a theatre, and then goes along the x-axis. So you need to be able to sketch those and transformations of those and be able to put the equations of those asymptotes on. This one is x is 0 and y is 0. Now remember, what I'm doing today is just a triage of what you haven't learned yet. We are not doing revision notes. The revision notes are coming later. So all you're doing at the moment is ticking off. Now, number 17 is not technically in the first year specification, but I've put it in because I think it's really good for you to understand things like exponential modeling. So in exponential modeling, we often look at the long-term prediction of the function, and understanding the asymptotes in a function such as 2x add 1 over 3x minus 1. Understanding that graph there, it's basically a 1 over x sort of, but transformed. It is 1 over x transformed, but you don't think of it in terms of transformations while it looks like that. And it's going to really help you with fully understanding graph transformations. It's going to help you think about algebraic division and how useful it is to write different expressions in different ways. And it's also going to help you when you come to do exponential modeling. So you may think, oh God, I don't know that. Don't worry, but you can put it down as a maybe if you want to. Inequalities, you need to know how to solve linear inequalities, move it all around, flip the sign if you times or divide by -1. All fine with that. Quadratic inequalities, which is where you factorize and then you think about the graph and you're either I want to be in between the roots or outside the roots. Now, sketching inequalities is one that I think maybe a lot of people are going to need some help with. Sketching inequalities is things like sketch the region y is less than 2x and y plus 1 minus x is bigger than 0. So it's two-dimensional. It's got x's and y's in, and we're finding a region of the xy plane and colouring it in. That's what sketching inequalities is. Now, the number that you see, that's the number of the lesson in the TT course. Now, obviously, you've got textbooks as well that you can learn from, but if you have the TT course, the number there is the number of the lesson, so you can go straight to it and fill in that gap, okay? I'm going to have a really quick look at comments to see what you are saying. Nothing? Any questions before I go back to the next one? Okay, all right? Oh, thank you for whoever's, shall I just go like that? Okay, I will just, when I pop back in, I'll just block anyone who's spamming you, okay? Right, back to this. Algebra. This is going to be super fast. You should all be totally fine with this. Remember, this is first years. Next hour is second years. Indices and surds are really badly answered, so practice it. But I'm sure you've learned it. Rules of indices and then rationalizing the denominator. Fractions is basically adding fractions, multiplying fractions. Factorizing is factorizing quadratics and factorizing cubics. Okay, now the cubics that you're going to factorize, there are two types. There are the ones with a common factor of x, that you just pull the x out the front, then you've got a quadratic. And there's the ones where you can spot a factor. So there are also cubics you need to keep an eye out for, where even though they don't tell you, it's not the factor theorem, they don't tell you that x minus 1 is a factor. You look at it and you think, wait a minute, if I put -1 in, that will equal 0. So I now know that x plus 1 is a factor, and now I can use the division. Factorizing is a really important skill. It's kind of similar to the indices, surds, fractions, that people don't think it's hard, so they don't practice it, and then that's where they lose the marks. But what we're doing today is a recce. We're doing a triage. We're just finding out what you haven't done yet, so don't worry for now about that. Completing the square. Do you know how to complete the square? Do you know how to complete the square when there's a number in front of the x squared, like 3x squared plus 2x plus 1, or minus x squared plus x plus 3. Can you complete the square? That is absolutely vital skill. It's really, really important. Simultaneous equations, most of these are going to be one linear, one quadratic, but it could be one this and one that, where these are anything. The general idea is that we make one of them say y equals or x equals, whichever's easier, and stick it inside the other one. It's the general idea for simultaneous equations. And then at the end, we try to remember to go back to get the other coordinate. Hidden quadratics are something that you should know about. This is where it's a quadratic, but it doesn't look like one. So you might get 4 to the 2x plus 3 lots of 2 to the x plus 1. Or you might get sine squared x, add 3 sine x, add 1. Or stuff like that. Things where there is something squared. Or the one that catches people out, x, add 2 root x, add 1. That's a quadratic. So hidden quadratics are worth practicing, but once you recognize it's a quadratic, it's just your normal stuff, factorize, complete the square, or quadratic formula. Factor theorem and division, number 7 on the Tailored Tutors content guide. If you want to go have a look, my method is, it's called synthetic division. If you've been taught algebraic division, then you don't have to do algebraic division. We used to teach algebraic division because you had to be able to divide by quadratics. But now, boom, boom, new spec, don't have to divide by quadratics. You only have to divide by linear things. So you can do this beautifully simple method called synthetic division. And it's so easy and you don't get in a muddle and it's just brilliant. So check that out if you have learned algebraic division, you don't need it. The factor theorem is what links up a factor and a root. So a graph slices through the number 2. As it slices through the number 2, that shows you that one of your factors of your function is x minus 2. So it's a pictorial representation as it slices through of what the actual expression looks like. Binomial expansion, there are a number of ways of doing this. The way that I do it, you can use exactly the same method in the first year and the second year. And I've had lots of feedback that people find this super duper easy. So you should have learned how to do the binomial expansion. If you want to do a method that you can also do next year so that you don't have to learn a new method next year and it's complicated, then check that out. Okay, I'll have a quick look at comments again and then we'll move on to trade. Comments, questions? Right, so do we have to print out this map? You don't have to, you can use it however you like, okay? I think there's a delay as well, so I don't think I can tell exactly when you're asking questions, but I'll keep popping back and having a little look. We've got 31 minutes. My phone is dying, so I'm going to plug this in. It's good to have a focus in the timer. It really keeps you motivated, especially like at the moment when it's really hard to be motivated. Right, how can I move this left and right, I wonder? Maybe like this. Trig. Okay. Sketch and understand y is sine x, y is cos x, and y is tan x. Various ways of doing this. My preferred method is to think of a circle. The angle is how far round you've gone from the positive x. That's what the x is, the angle round. And then wherever you land when you've done that, you can either measure the distance to the x-axis, straight down or maybe straight up, that's sine. The distance to the y-axis, so maybe that point on the circle, just have a look at the y-axis. How far in is it? Or from the other side? That's cos. And then the gradient of the line from the origin to where you are on the circle, that's tan. So they're really physical things that you can imagine. They're not these weird abstract things or things produced by a calculator. Understanding them makes everything a lot easier, I think. Now, for the first year, you only have 2 identities to learn. Sine squared x plus cos squared x is 1. We don't usually use it like that. We use sine squared is 1 minus cos squared, or cos squared is 1 minus sine squared. Sine over cos is tan. Sine x over cos x is tan x, is how I should say it. So you should know those and you should know how to solve equations. Now, again, there are lots of ways of teaching solving trig equations, but I am an examiner. I've examined for a long, long time and taught thousands of students. And the cast method is the one that the students get most wrong in the exam. There's too much premature rounding. Students get confused on what it is they're looking for and they miss solutions out. So if you've been taught CAST, then have a look at my video number 33, at 33 even, on how to solve equations. It's a beautifully algorithmic, simple procedure that you can use. Okay, for now, all you're doing is just ticking off the ones that you've done or highlighting the ones you haven't done. Okay, geometry. I don't actually know how to move this left and right when I zoom in, which is a bit weird, but anyway, geometry. So equation of a line, y equals mx plus c, mx minus a is y minus b. Geometry in general of a line. Midpoint, that's the average x and the average y. Gradient, change in y over change in x. Parallel lines, same gradient. Perpendicular lines, one gradient is a negative reciprocal of the other gradient. Have you done all that? Have you learned all that? Probably. Circle equation. How do you get the circle equation? If it's all expanded out, you complete the square. Really vital to know that the tangent to a circle is perpendicular to the radius. Really, really, really important. Any tangent to a circle anywhere is perpendicular to the radius at that point. Really important. Cosine rule and sine rule for triangles. So sine rule is where you've got an opposite pair. Sine that divided by that is sine that divided by that. And area of a triangle. Two areas of a triangle. Need to know both. Quite often half base times height is going to be 1,000,000,000 times easier than half AB sine theta. So tick off, that's the whole top. We've now got 27 minutes. We're going to move on to row 2. Has anybody got any questions? Where is the chat? Anybody got any questions so far? Yeah, graph sketching, Aisha, I think. But for the moment, just for this session, let's work out what you haven't learned. And then we can talk about what's the best way to learn what you haven't learned. I'm going to be doing that with you, doing sessions. And also, what's the best thing to do for things that you did learn, but actually you can't do because they're different sections. So for today, we are very much just identifying things not learned. Okay. Okay. Year 13 is at 1 o'clock. Right, row 2, exponentials. So you need to be able to sketch e to the x, which comes along the x-axis and then shoots up exponentially, and transformations of that, just graph transformations. Exponential modeling is understanding what the structure of an exponential model is. So it's going to be a number, and then another number, and a power. And that power can have, or it can be quite complicated, that power, so long as the variable is up there, the t or the x has to be up here in the power. So the most common exponential model is a, capital A, e to the power of kt. That's usually the one you're going to be working with, a, e to the kt. So if you don't know what I'm talking about, then this is the section you need to work on. Okay. Right, log functions. Log is the inverse, the opposite of the exponential function, and we need to be able to sketch it and solve equations using it. Exponential and log equations, what I mean here for 29 is literally not using log rules, literally just if I gave you the equation 3 plus log to base 2 of x add 1 is 4. Would you be able to solve that? Just some numbers and stuff and a log somewhere in there. Would you be able to solve the equation and find the x? What if I did e to the 3x add 1 equals 2? Would you be able to solve that equation? Do you know how to get an x from out of an exponential or out of a log? Log rules, there are 3. So if you know these 3, you know all of them. They are log a plus log b is log ab. Log a minus log b is log a over b. Log a over b, not log a over b. No, log a over b. And log x to the n, pull the power down the front, n log x. So if you know those 3 rules, then you do know everything you need to know. Linearizing data with logs is this quite tricky topic, and it's either in stats or it's in pure. We're not quite sure where it goes, but this is where we've got some data and we've plotted it on a scatter diagram and it looks amazing. It's going like, woo, like it's not a line, it's definitely some sort of curve, but maybe it's x squared, or maybe it's x cubed, or maybe it's e to the x, we can't see. So putting a regression line, a line of best fit on, not possible. But if you change the data, if you plot x and log y, or sometimes if you plot log x and log y instead of x and y, then you get a beautiful straight line. Then you can find the line of best fit, and then you can go back and work out the original equation. So either you don't know what I'm talking about, in which case you definitely need to highlight 31, or you do know what I'm talking about, but you know you can't do it, in which case maybe highlight it as well as something that needs to be come back to. Differentiation and integration and trig are the three biggest things. Just so that you know, differentiation, integration, and trig are the whole foundation of the second year, okay? The rest of it, you could not be able to do, and we'd be able to wing it and sort it out and it'd be all right. But if you go into the second year and you don't understand and can't do integration, you don't understand and can't do differentiation, and worst of all, you don't understand and can't do trig, then there's nothing to build on. So those three, in terms of you thinking all the way to this time next year, it's the differentiation, the trig that are absolutely key, okay? For now, differentiation and integration, quite straightforward. So differentiation, we only need to differentiate number x power, that's it. So you do need your rules of indices quite a lot with differentiation and integration. Often that's what causes the problem. So differentiation, pull the number down and take 1 off. Integration, increase the power and then divide by the new power. For differentiation, you need to be able to make equations of tangents and normals. So this is where I've got a curve and I find the gradient of the tangent by differentiating. And then I can make the equation of a line just in the normal way that I would up here, like I did in lesson 20. Stationary points, dy by dx is 0. Stationary points are either maximums, so they go up, 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 stop, down, 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 or minimums, down, 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 stop, up, up, up. At that stop point, maximums and minimums, that's where dy by dx is 0. The gradient of the tangent is 0. So you need to be able to differentiate, which usually involves indices, then put equals 0 and solve. Then to classify them as maximum or minimum, you need the second derivative. So you differentiate the derivative, shove the point in, see what you get. And there are rules for how to know which is which. So maybe you've done that, maybe that is all like, whew, in which case, tick it off. Optimization problems are basically stationary points, but in a context. So optimization problems are like, oh, I've got this cup and the volume is 500 milliliters and I want to minimize the amount of surface area that I make the cup out of, but the volume has to be 500 milliliters. Stuff like that. Part A is simultaneous equations. Part B is differentiate, make it naught, solve. They're always the same, but they're algebraically quite heavy and you can get lost in, it's a bit like it feels like you're getting tangled in weeds or something and you just can't move. There's just algebra everywhere. So they don't require any extra knowledge, but they do require some practice and confidence building, okay? Integration. After you've integrated, you must remember plus c. It's often forgotten. The only time you don't need plus c is if you have limits. So what you need to know is that you take that top limit and feed it in first. Then there's a minus, and then you take the bottom limit and feed it in second. Show your working, show us what you're doing so that we can give you all of the marks. The hard application, oh, I forgot first principles, I'll come back to that in a minute. The hard application of integration is areas under graphs. That can get really tricky. The basic information is that if you integrate from here to here, you get that area. But then the actual questions that you can make, they can be really, really difficult. So knowledge-wise is a very common thing in maths. Knowledge-wise, how much do you have to know? Nothing. If you integrate from A to B, you get the area from A to B. Done. That's the knowledge. actual application, it can take a lot of practice getting used to these different types of areas and how to build them up using integration, and how to be careful with the bits under the x-axis that would be negative areas, whatever that means. So make a judgment call for yourself whether or not you think that's something you need to go back to. I'm looking at comments. Plus C tried to kill everyone. Lawrence, what is it you were saying? Well, you don't know when to use a natural log. And what the heck is linearizing data? Yeah, I think exponentials might be something that I need to do with you pretty soon. I'm going to ask you, when we get to the end of this, I'm going to ask you what you want, and then we're going to plan out the rest of this week. Okay. So what your email for a code for the classroom? I don't know what the code for the classroom is. Is that for me? He is giving all the work, asking for the code. I'm reading this backwards. That's probably silly, isn't it? Maths work on Mr. Annis' classroom. Cool. Any work that you've got, I can help you with. So don't worry about what your teachers are setting. You can just tell me what your teachers are setting. I'm going to set up a page for you to upload it, and then that will show me what you need help with. Okay. The linearizing data with logs is quite tricky, and if you didn't know what I was talking about with that, making it go from y equals ax to the n to log y is p plus q log x. If that's like you don't know what I'm talking about, then linearizing data with logs is something you haven't done yet. Modeling with logs, Yoda Master saying modeling with logs is pretty difficult. Yeah, it is, but so long as you know the structure of an exponential, so the structure of an exponential function, the actual algebra is number e stuff with an x or a t. So usually a e to the kt, and the only things we're missing are the k and the a. So if we can get given some information, we can sub in, well, when t is 0, y is this. Sub that in, have a look what you already found out. Or maybe they tell you that after 5 days, the pandemic has hit this many people. So then you sub in t is 5 and y is that, and then you get some more information. So, right. Okay, first principles. So first principles I forgot to mention in differentiation. Now this is not hard, okay? And it's also not a big deal. So please don't stress. Linearizing data with logs, that could be worth quite a few marks. That could be worth, well, easily 10 marks. Whereas first principles, you're talking about 5-6 marks at the absolute most. It's not a big deal, and it's also pretty simple. It's working out, you know, when you differentiate, you pull the number down and take 1 off. It's just proving why that happens. And I could teach you it in 5 minutes and you'd be able to do it within 20 minutes. So don't stress about it, but tick it off if it's something that you haven't learned. In terms of like you thinking, I don't know if I have learned it, see whether this rings any bells. It would be a fraction, and it would be the limit as h tends to 0 of f of x plus h minus f of x all over h. Limit as h tends to 0 of f of x plus h minus f of x all over h. If that means nothing to you, it's first principles that you haven't done yet. Okay, vectors. Now, vectors seems really hard. And that is true. It's not worth as many marks as you'd think. It isn't worth anywhere near as much as trig, differentiation, integration, and graphs. That's worth the most, I think. In fact, I think I probably should have swapped graphs and no, I think probably this is worth more marks. By the time you add up all the times you do this, it's worth more marks than graphs. But vectors not worth loads, and it is quite tricky. So it's a good one not to leave till last. Now, I haven't got the book with me, but where is vectors in the book? It's the last chapter. So when do teachers do it? At the end of the year, when they're rushed and they haven't got much time. Same thing with integration. The textbook is not written to be followed. that it's just a collection of facts. The idea is that teachers, with all of their experience and all of their knowledge about how people learn, then take all of that information and choose a structure with which to impart that knowledge and for students to be able to weave around the spec and build it up. Now, if you start on chapter 1 and just go forward steadily like that, then what happens is that you hit vectors and integration right at the end of the year when you have no time, and they're the hardest things. So my mission is to stop you guys, you're all in the first year, it's to stop you guys this time next year being in a situation where you haven't started the integration and the differentiation that are the core of the A-level exam next year. So even though this now doesn't seem like a really big deal, and the trig, massively the trig, that's where I want to focus you the most, but I will cover anything that you haven't done. Vectors, you need to know how to find the length of a vector. That's using Pythagoras, that squared plus that squared square rooted. How to find the direction of a vector. That's a pain, but basically it's using inverse tan. So if you know that the vector is like 1, 6, then that angle in there, the opposite is 6 and the adjacent is 1. And you can do tan is the opposite over the adjacent and then inverse tan. But if it's going that way, then it's like, well, do I measure that angle, or is it bearings where it's like that angle, or, oh. So direction is just inverse tan, but it's a bit of a pain. Length is Pythagoras, the length of a line, that squared plus that squared square rooted. Angle between vectors, that's, you just draw a triangle and you do the cosine rule. Literally, it is the cosine rule. The angle between vectors is the cosine rule. You draw it, that's the angle you want. You work out the length of that one and the length of that one using Pythagoras. You work out that vector and work out the length of that one using Pythagoras, and then you do the cosine rule. It's just a triangle. Unit vectors students don't like, but they're just ones that have a length of 1. Whoop. So if they're really, really long, they're not unit vectors, but we stretch them. We shrink them to make them length 1, and then they're a unit vector. And if they're really, really tiny, then we stretch them until they have length 1, and then they're a unit vector. So we're just stretching them or shrinking them. Parallel vectors, they have the same gradient, is one way of thinking about it, but the other way of thinking about it is that one of them is the other one times by something. So if I shrink this one, I get this one, or if I stretch this one, I get this one. That's what those are. So if you think, yeah, I did sort of know all those things, then maybe that's not something to worry that you haven't studied. It's just something to come back to and work on. Right, number 25, adding vectors. So you should know that vectors are like pencils. So if I do this vector, add this vector, then, and I was trying to draw what was happening, what it means is that you get that vector, and then on the end of it, you put that vector. So maybe I'd end up there. So the net result, when you add vectors, if I do white pencil, add blue pencil, that equals this, that diagonal. So if you picture it, the best way really to picture it is as a parallelogram. So imagine if I had another white pencil there and another blue pencil there, then A add B, or white add blue, is the diagonal line through the parallelogram made by the two vectors. So that's what adding vectors tip to tail is. If you already knew that, then great. So it's like if I want to go from A to C, that's the same as going from A to B and then from B to C. That's all that's saying. The only real formula you need in the whole of vectors is that one there. A to B is B minus A. If you can just have that in your brain, if you already know it, then you're pretty much done. A to B is B minus A. That's the most useful and pretty much only formula that you need in the whole of vectors. The rest of it is problem solving. They can ask you to prove that something is a square, rectangle, rhombus, parallelogram, trapezium, or they could say, here are some coordinates, there's another coordinate and it makes it into a square, what's the other coordinate? Or it makes it into a trapezium, what's the other coordinate? So you do need to know, like, what are the features of square, rectangle, rhombus, parallelogram, trapezium? What are they? What shapes are they? And how would you prove that a bunch of dots makes a parallelogram, for example? So quick reminder before we go on to proof is that all of these numbers are the Tailored Tutors videos covering that whole topic. Each video is about 10 minutes, okay? So in theory, you could watch the whole lot. There's 60, in the whole AS, there's 60. So if they're 10 minutes each, you could do 6 in an hour and there's so 10 hours. You know, 2 hours a day for a week, you could watch the entire thing and make beautiful notes if you wanted to, but there's no reason to go that fast. We've got time. Okay, quick look at chat and then proof. For the next hour tomorrow, what do I suggest you come prepared with? That's a good question. I will tell you at the end when we decide what we're doing. Optimization in differentiation is where they say I've got a cylinder and it's got a surface area of 6 meters squared. What's the maximum volume I could have, or something like that? Yoda Master, you have to do your AS and A levels in 2021. No, you won't need to do your AS because the AS doesn't contribute to your A level grade at all. Literally, it's irrelevant. It's just a separate qualification. So it's not that you take AS and A-level exams, you will just do your A-level exam in 2021 or September this year if you're in the second year, or next June if you're in the second year. Okay, right. Lawrence, remind me at the end. Okay, in a minute, I will stop screen sharing and then I can just answer your questions. So last thing, proof. We've got 8 minutes of our action hour and then we have to have a break. It's a rule. So proof is difficult, okay? There are even proofs that they put in that I think, what do you want me to do? I don't get what you want me to do. And then when I look at the mark scheme, I think, oh yeah, okay, but I wouldn't have thought of that. So there are some proofs that you just can't prepare for, but there are lots of proofs that are standard. So they really like even and odd proofs. Prove that any integer cubed is a multiple of 4. So you go, okay, I'll take an even number and I'll cube it and I'll see if it's a multiple of 4. I'll take an odd number, 2k plus 1, and I'll cube it and I'll see if it's a multiple of 4. Whether or not things times together or added up are still even or odd. So prove that the sum of 2 even numbers is even. Prove that an even plus an odd is odd. Prove that a rational times a rational is still rational. Find a counterexample to prove that not all rational numbers, I don't know, are positive, something stupid like that. So those are the types of proof, but you will never ever, even if you do proof every single minute for the next 6 months, have fully prepared yourself for proof. So don't spend a huge amount of time on that. All these blue things at the bottom, not worth that many marks. Now, numerical methods and sequences are second year things. I put them on there because the second year map is exactly the same as this. What you do in the second year is you build on these things. So you do more algebra, you do way more trig, way more differentiation, way more integration, no more vectors, a tiny bit more geometry, not really much more on graphs, but you do learn about functions. Do a tiny bit more on proof and you learn about numerical methods and sequences. But what you do not want to do is go through the book in order. So please subscribe to Tailored Tutors and let me make sure that this time next year you are 100% prepared. Right, take a look at what you've written down. What I'm hoping is that you have now got an idea of the sections you most need help with. What I would like you to do first is to choose one, just one, okay? Which section have you done the least in? And just put that in the chat. So either your options are graphs, algebra, trig, geometry, exponentials, differentiation, integration, vectors, or proof. If I was going to do a lesson tomorrow, what would you choose for the lesson tomorrow? Okay, just you say whatever you want, okay? Because I can read this chat later and I can have a look through and that can inform us on what we're doing. Okay, so I think that the most common answer is exponentials. So what we're going to do, let's have a look at the, let me share that different thing. Where's the exambulance? Have you all got your exambulance? That's important. Here's the exambulance. Okay, so you go to the Tailored Tutors website, you click on Maths Exambulance and you get the exambulance. This is the map we were looking at. This week, we're going to focus on, let's have a look at the study schedule and see what I said I was going to do this week. And it looks like we're going to start with exponentials tomorrow. And I'm just going to keep updating this based on what you guys want, okay? So we are in, let's have a look. We are in phase 1, finish the AS content and make notes for the first year. I was going to do geometry, trig, differentiation, integration, vectors, and I wasn't going to do exponentials until down here. But what I'm going to do is I'm going to pull that back up here. I'll have a look at what other things you said you would like, and I'll make a plan for this week that hopefully will work with you to help you get it done. Somebody asked, what resources do we need? Very good question. What you do is you go to Maths Revision Notes in here. And so tomorrow we're going to do exponentials, okay? I'll pull that schedule, change it to exponentials and put that back up. And in the AS and A-level revision notes, I think we can search in there, can't we, for exponentials? And hopefully find it. No, that's force acceleration diagram. Here we go. This one. You can go away now. Yes, you can go. Thank you. You have done your job. Go. I don't know how to make it go. Here it is. This one here. So we're doing exponentials. So this is the page that you would print, and we are going to make the notes on this page. Okay, so this will be summary notes. That stuff down there, that's the linearizing data with logs that I was talking about. These down here, these are the Tailored Tutors videos covering that whole topic. If you've got a subscription, you can go to them. And this link here, if you want to get ahead on any of these or do a particularly different one, then that link there takes you to a revision class where we're filling in this sheet. So you might think, oh, well, I'll come tomorrow at 12 to do the exponentials and logs, but actually I would quite like to do the proof one myself. Okay, so these are all downloadable. They're all in your exambulance there. And over the next few weeks, we will get through as many of these as possible. So you will have as many as possible covered in your full revision notes. Okay. Any other questions? We have still got 2 minutes, and then the rules of action hours dictate that we set an alarm for 10 or 15 minutes. If you do this, right, you're going to be studying from home now. I promise you, I work from home. I use action hours all the time, and I am way more productive when I use them. If I just sit down in the morning with a coffee and keep going, by about 1 o'clock, I'm a bit brain dead and I'm just not really doing much. If I put the timer on and I do 45 minutes, 15-minute walking around, do something else, 45 minutes, 15 minutes, I am so productive in the day. It is amazing. So for you guys, in terms of what's happening the rest of today, 4 till 5, I'm going to be doing a study with me every day. So if you've got work from your teachers and you're finding it difficult to motivate yourself, then come online at 4 o'clock. We're going to be doing 45-minute action hour, totally focused studying. I will be answering questions on the course, on the Tailored Tutors course. So if you've put any questions in there, I might be answering your question in there. And then at 6 o'clock today is our check-in, when we're going to be talking to you all about anything you're worried about in terms of the A-levels. Okay. Every single day at 12 till 1, I will be doing this. And from 1 till 2 is the second years. And let me see if I can see just before we go, see if anybody's got any other questions. I mean, you know where I am, okay? And you can also, in the exambulance at the bottom, you'll see comments. If you have got questions, you can put them in there, okay? So I'm sorry I didn't have the chat on the whole time there. I hope I answered your questions. I'm going to scroll back through it now and see what topics you wanted and make a final plan for this week. But for sure, I will do exponentials tomorrow at 12 o'clock. Okay, let me know if you've got any questions at all, and any more that I can do to help, please let me know, because as Rich said earlier this morning, we are winging it at the moment. We are just making it up as we go along. So if you can think of anything that we could do that maybe we're not doing, then please let us know. Okay, timer is going on. This is how action hours work. I am going to do a 10-minute timer, not a 15, because I've got to teach my second years in a bit. So 10-minute timer is on. I'm going to go get a cup of tea, walk around a bit, maybe walk upstairs and walk back down. And I will see you second years in 10 minutes. And you guys, I'll either see you at 4 o'clock or at 6 o'clock or tomorrow. Take care.